Okay, so let's find some absolute extrema. So find the absolute extrema on the following functions for the following functions. So f of x is equal to 2x squared minus 8x plus 1. So we're going to start with f prime of x, which is going to give us 4x minus 8. We need it to be a critical value, so we're going to set it equal to 0 and solve for x. So 2 is one of the values that we're going to plug in and kind of evaluate. We also need to evaluate 0 and 3. So we're going to pick some x values and some f of x values. So we're going to plug in 0, 2, and 3. So if we plug in 0, we're going to get 1. We're going to plug in 2. Which gives us 2 times 4 minus 16 plus 1, which 8 minus 16 is negative 8, plus 1 is negative 7. And then we're going to plug in 3. Three squared is 9. 9 times 2 is 18, minus 24, plus 1. 18 minus 24 is negative 6, plus 1 would give us negative 5. So when we are looking at this, the biggest value for y is 1, and the smallest value for y is negative 7. So we have an absolute max. The absolute max is 1 at x equals 0. The absolute min is negative 7 at x equals 2. Okay, and then we're going to do the same thing. So g of x is equal to this function. We need to decide the critical points and then test the endpoints and everything else. So g prime of x is equal to, dividing by 2 is just a constant, so we're looking at the derivative of x squared minus 1 squared divided by 2. 2 times everything, because it's chain rule. The 2 times would get rid of the division, so we have x squared minus 1. And then we need to multiply by the derivative of the inside. The derivative of x squared is 2x, and then minus 1 goes away. We're going to set this equal to 0, so we have x squared minus 1 and 2x. We're going to use our zero product property to look at x squared minus 1 equaling 0 and 2x equaling 0. 1, what squared equals 1? Well, that would be plus or minus 1. And 0 for x. So we have quite a few values here to test. We have negative 3, negative 1, 0, 1, and 2. So now we're going to go ahead and just plug this into our function and see what we kind of can get. So negative 3, negative 1, 0, 1, and 2. So negative 3 squared minus 1 squared divided by 2. Negative 3 squared is 9. 9 minus 1 is 8. 8 squared is 64. 64 divided by 2 should be 32. We have negative 1. Negative 1 squared is 1. 1 minus 1 is 0. 0 squared is 0 divided by 2 is still 0. 0 squared minus 1 is negative 1. Squared is 1, so we get 1/2. 1 squared is 1. 1 minus 1 is 0. So we're going to get 0 again. And then this last one. Two squared is 4. 4 minus 1 is 3. 3 squared is 9. So we get 9/2. So we have an absolute max being 32. And this happens at x equals negative 3. And we have an absolute min being 0. And this happens at x equals negative 1 and 1. Okay, one thing you're going to notice is that I've already pre-written out the next couple. So we have h of x being x squared divided by x plus 3. So we need to find the critical points if we have any. This is going to take the derivative, set it equal to 0. Well, our derivative, once we simplify everything is x squared plus 3 divided by x plus 3. Well, if we set x squared plus 3 equal to 0, we get negative 3 equals x squared, which is an imaginary value, so we don't have to worry about this as a critical point. The other thing we need to keep in mind is undefined slopes. So when the denominator is equal to 0, that would happen at negative 3. This is not on our interval, so we don't have to worry about that either. So we're going to take our endpoints negative 2 and 1 and plug them into our function h of x. So when we do that, we get negative 2 gives us a y value of 4, 1 gives us a y value of 1/4, so we have an absolute maximum at 4, and absolute minimum at 1/4. Our function here is continuous on this interval, negative 2 to 1, which is why we know that this is going to be our answer. And then our last one here, we have y equals 2 sine of x minus x on the interval 0 to 2. We take the derivative to get 2 cosine of x minus 1, set it equal to 0, and we're going to solve. So we get 1/2 is equal to cosine. This is going to happen when we are at that pi over 3 angle, so pi over 3 and 5 pi over 3. So those are going to be our critical points. There's no values here that are undefined, so we're going to look at 0, pi over 3, 5 pi over 3, and 2 pi. When we plug everything in, we're going to get some values that are a little bit hard to kind of gauge. Things that we can know, square root of 3 is less than 3, and pi over 3 is it's a little bit more than 1. So if I am looking at this, I know that it's going to be bigger than 0, but less than 1. So I know that's when I put it in the calculator, I got 0.685. When I look at the next one, the square root of 3 is less than 2. So if I have this at the maximum, negative 2, and then minus 5 pi over 3. 5 pi over 3 is 5/3 of pi, so it's going to be less than 6. So we have a little bit less than 1, and we are subtracting 6, and that answer is not quite right. So let's re-put it in. So I have negative square root of 3 minus 5 pi over 3. And if we do that, we're going to find out that that is almost 7. So it is about negative 6.968. And if we're talking about 2 pi is about 6.28. So negative 6.28 would be 2 pi. This changes my answer just a little bit. So our absolute maximum stays at pi over 3. Our absolute minimum, on the other hand, is the negative square root of 3 minus 5 pi over 3 at x equaling 5 pi over 3. So the big thing with absolute extrema is that we need to find our critical points anytime our slope is undefined, and then also test those endpoints. From there, it's just evaluating and looking at y values.